Hi everybody. Today I'm going to talk about how to cut threads on a rod, so a steel rod, and to cut internal threads in a piece of steel that you want to thread that rod into, or a bolt, that kind of stuff. First we'll look at a couple of bolts. In another video I'll probably be talking in greater detail about the specifics of thread pitch and diameter and all that kind of stuff, but today I'll just point out the fact that if you have a couple different bolts, these are the same thread size, this diameter and pitch, but you can see that on this one the length of the thread is here about 1.5 inches maybe, and on this one the length of that thread is about 2 inches, but also it goes all the way up under the head of the bolt, right? And that's an interesting feature. And there's a lot of good reasons why one is good for certain things, the other is good for other things, and so on. But what I'm going to do today of interest is to create threads on a plain rod. And if you look carefully at that piece of steel, and I'm going to put this behind it so hopefully the camera focuses well on just the rod, that's just a plain 1/4 inch round piece of steel. And I've just ground it nice and smooth on the end so that it doesn't interfere with me starting my thread cutting. Okay, and I'm going to make it so it's got like a little bolt part right up here we could put a 1/4 inch knot onto, right? And the other thing I'm going to do is take a piece of steel that's just got holes in it and thread those holes so that the two would fit together. Now I'm going to take the camera off for a second and look at an example of a threaded hole, right? This is an engine, a small gas engine. This one, just for reference, this one has a cutaway feature here, so when I do this to show my students how the engine works, you can see what's going on. This engine's not going to run again. This was part of a lawnmower. The lawnmower had a fatal accident, and so then I cut holes in it and stuff to use it as a teaching device, but of course it can't run anymore. Here's an example of an engine, similar engine, where you could actually put gas and oil into this engine and it would run because all those pieces are still intact, right? Anyhow, looking carefully here at these holes, you can see that they've been threaded. Someone has used a tap to cut threads in there, and then this bolt here fits into those threads. It's very strong, and that would, you know, in this particular instance, it would hold the head on top of the cylinder, you know, like that, and seal up the top of the engine. Again, keeping in mind that I've cut away some stuff here so you can see things going on, but that's the way that would work. So we'll go over here now, and I'm going to take my steel, and I'm going to come over to my setup here. What I have here is a thing called a tap and die set, right? And tap and die set, in this particular case, it includes coarse thread and fine thread taps and dies, and includes inch sizes as well as metric sizes. Okay, and the metric and inch distinctions are important, but I'm not going to really go into detail about that today. But we'll know that they exist. And here we have in this section, these are the inch sizes, and these are the coarse thread, and this is inch sizes, and they're fine thread. And you can see, hopefully we can see there the difference between the two. The coarse thread ones have fewer threads per inch, fine thread more threads per inch. Different applications, you know, they're better for different applications. These things here are called dies, and they're going to cut the external threads onto a round piece of material, right? And I'm going to show you how to use that in a minute. And of course, this side over here is all the metric versions of the same thing. To know that the terminology here a little bit, say tap and die, and then this guy here is where you put one of the dies into, and you use that, you know, use this as a handle to have the leverage to turn this on the rod, and that's called, this particular tool is called a die stock. Okay, don't know why it's not called a die handle, but just to be accurate, this is called a die stock. And then over here, this kind, and you can see how as I turn this, it opens and closes those little jaws there, and we open that up. We can then fit a tap into here, like that. Okay, and that gives me leverage to turn the tap. This is called a tap handle, right? Okay, and I get that nice and snug, and that'll hold it, and it'll give me a good leverage to do my work. Okay, so what I'm going to work on next is to cut internal and external threads in a piece of steel. Okay, so I'll focus my camera here on this piece of steel. I have, what I have here, first of all, is a chart, and it doesn't really matter if you can read this real well, but this thing tells me exactly what size holes I would drill into the material to go with the different size taps, right? So I've gone through here and figured out that my 1/4-20 tap is what I'm going to use today. So 1/4 of an inch nominal diameter, 20 threads per inch, right? That's what this one, if you, I know it's probably hard to read on there, but you just have to believe me, it's engraved in this thing. 1/4-20, 1/4 of an inch nominal diameter, 20 threads per inch. Okay, and I'm gonna put this in the handle, the tap handle, like that. Okay, and I'm ready to cut that. And I have already drilled a couple sample holes in this piece of steel. I'm going to zoom in here and see that I've used this piece several times for this kind of a demonstration. So right now I've got 4 holes here that have already been tapped and have the threads in it, 3 holes here that I've just drilled and are ready for me to tap. And of course, it'd be exciting, I'm sure, to watch me tap 3 different holes, but of course I'm just going to do one for my demonstration today. I should have somewhere here. Okay, I'm going to stop the tape for just a second and go get my oil. I'll be right back. Okay, I'm recording again. So I've got some very simple lightweight oil. It's perfect for this kind of application. If you were doing higher speed thread cutting and larger pieces of material where you're experiencing a lot of heat and friction, there's special kinds of oil for this operation. But for this kind of thing we're doing right now, some regular lightweight machine oil, 3-in-1 oil, is perfectly suited to what we need to do. I'm going to go ahead and put on my safety glasses just for the record. We want to be safe all the time, even if this is not considered like generally a big hazard for flying stuff to come off of it. I'm going to put some oil there in the hole. Now here's the tricky part. This is the beginning part of cutting the threads is always the hardest part. What I've got to do is I'm going to turn this clockwise to start it into the hole. At the same time though, I need to keep this perfectly level, keep these handles moving in the same plane all the time, or at least as best I possibly can. So I have just the right size hole here. The chart told me a number 7 drill was just right. And I am turning this carefully, the same direction clockwise. And at some point it's going to start to really cut in and make a thread in the hole. And at that same time I should be able to see a little tiny curl of steel coming up, or whatever material your base metal is here. I get a bit coming out, and it's actually going to start to jam up my turning, like just a little bit. And at that point now I'm going to rotate backwards, counterclockwise, to break off that chip of steel. And then I continue, I turn clockwise again, a little bit, about a half a turn, and back up about a 1/4 turn to break off the chip. So it's actually cutting away metal inside that hole. These little grooves are sharp, and this is a hard piece of steel, much harder than this mild steel I've got right here. This piece here is, even though it's a thick piece of steel, it's not hardened. So the hard steel of the tap, which is excuse me, about as hard as about as hard as a drill bit. So that's pretty hard. It's also brittle. I have to be careful not to bend it as I'm doing this. Forward a half a turn, reverse a quarter turn, and you can just feel when I go like this, I say, oh, that's creating a lot of resistance to me. I'm going to go backwards and break off that chip, and eventually I should have little pieces of metal falling out the bottom. Now you want to be careful about doing what I just did there. That's really easy to give yourself a metal splinter. If you've ever had a wood splinter, it hurts. Metal splinters hurt even more. I'm going to take a little piece of little towel here and clean that off. Okay. So I'm going to keep doing every once in a while. I'm going to make sure I've got adequate oil going here, good lubrication. The lubrication is going to make this work easier. It's going to help keep the tap from getting too hot. It's also going to make it so that the tap is less likely to get damaged. You know, a tap has a service life. It's not going to go on making holes forever and ever, just like a drill bit. They get worn down, broken. The teeth get messed up after a while. A drill bit, of course, you can sharpen. A tap, not so much. You know, when the teeth on the tap get kind of beat up and dull and maybe missing some teeth or whatever, and eventually you just have to retire the piece and go get a new one. And of course, as often is the case, it's really helpful to have a great big set of taps and dies, but you know, there might be one like this particular size here, this 1/4-20, is definitely the one we use the most here in the shop. I'm actually making some progress here. I'm getting some threads going down into the thing. I'm trying to hurry it up now because I'm sure the story's getting a little dull now. Okay. Now, of course, I can feel, it feels like I've got threads going all the way through now. The tap has come through all the way. And I'm going to then carefully take it back out counterclockwise to loosen. It's just like I'm unscrewing the tap from those new threads, and I'm putting gentle pressure upwards to get the tap out, counterclockwise to loosen, and there we go. I'm all set. Okay, so let me now I can test this out. One of these bolts I brought out is a sample. This is a 1/4-20 bolt right here. I'm going to try it in the hole, and that feels all right. It's a little bit sticky. I think maybe my bolt might have some bent threads. I'll try a different one just for fun. Oops. Okay. Now I have a feeling we might have a little rough spot in these threads. I'm going to try to clean out the threads a little better. See, now that I've done this, I can run my tap through this hole again. I'm going to very carefully run it into those same threads. I don't want to get it crooked or anything when I run it in here. It has a chance to mess up the threads, right? So I'm going to just carefully run this in and out of the hole. Hopefully then I'll have a nice threaded hole in here inside that piece of metal. Okay, so here we go. Try that. That's pretty good. Yeah, that feels all right. Those are going in very nicely. Okay, so that's now this is a standard 1/4-20 bolt. These are made according to certain very accurate sizes and measurements. So there's any place I get a 1/4-20 bolt, if they're following the standards, which they all are, I go to Ace Hardware or Home Depot or a neighborhood hardware store, right? I get a 1/4-20 bolt. They're all the same, and that fits in there very nicely. Okay, so let's try now to go ahead and work on threading the the rod, right? So again, we have this steel rod, 1/4 inch, mild steel, low carbon steel. It's not hard, hardened. It's steel. It's hard if you hit yourself with it, and it's hard if you try to bite it, but it's just a round rod. And the thing I'm going to do here, now when I do this, I'm going to have to tighten it up in the vise pretty tight, because when I start to put twisting force on this to make threads, it tries very hard to slip. So what I need here is a 1/4-20 die, and of course, if I was a better teacher, I'd have it real close at hand. There it is. If we look carefully at this, you may or may not be able to see, but etched in here is the 1/4-20 etched in the surface of this die. Now the die has two sides to it, and hopefully on one of them it'll say start from this side. But when you look at these teeth and this setup here, there's more space in this open side here than there is here. This is closer together. So I'm going to start with this side towards the metal rod, okay? And that's going to, as it goes down the rod, it's going to start cutting threads, and it'll get deeper and deeper the more you turn it, right? And so it's going to be basically the same process as as cutting the threads with the tap, except that now we're cutting threads on the outside of this rod, and we're going to put a little oil on it as usual. Put the tap in here and tighten up this little set screw to hold the die in place. Now these little things in here, as I turn this outside thing here, this part is supposed to help me keep it straight by closing in on those little things. Come inwards on the rod when I do my tapping. I don't really find these to be that helpful, so most of the time I just leave them out like this. Maybe with a little more practice they'd be more useful to me or whatever, but whatever the case, I'm starting with that going towards the rod, and again keeping this thing, trying not to let it tilt one way or the other, up and down like this while I'm trying to turn it is not going to help. I need to keep it nice and level and turn it a little bit, turn it a little more, and there. It's hard for you to see on the camera, but as I look down inside here, I can actually see little bits of metal curling inside these spaces. And those spaces are there to allow those little tiny chips of metal that are being dug out of the big piece a room to go somewhere, right? So I'm keeping it well lubricated, and I'm going to go probably another half a turn right here, and I can see those chips of metal, and I go backwards, and those chips of metal should fall out. I go forward some more, backwards, forward. Yeah, here we go. You can see about half a turn forward, even a little more, and back up and let the chips fall out. Keep doing that. And of course, here's your design question: how much thread do I need, right? If I need a whole bunch of thread, or if I really, instances you really want your thread to stop at a certain place. When you put the nut on here, you only want it to go a certain distance. Well then, stop your threads there. If you need more threads, keep on going. Again, we're going to carefully unscrew this to make sure it doesn't damage the threads as it comes off, right? And there we have threads on the rod. Let me try to zoom in a little bit, and hopefully you can see how it looks like. I'm going to put this background behind it to try to get the camera to focus better. You can see how it should look like a bolt, right? I'm going to take the camera off and try to get a really good picture of that. There it is. Those are the threads. Okay. And let's try to then screw them into the threads we made in the big piece of steel, right? So I've got internal threads here that I have made, right? Right there. Those internal threads. They're in the third hole from the end, right? And then there's the external threads on here. Try that right there. And I'm turning it. Don't know if you can see that very well. Let me just see if I can get a better look at it. Okay. So sometimes the camera gets confused by the distance there. There's a pretty good shot. Okay. And again, we can look down at all those holes I've made in the past. All have threads in them, 1/4 threads. There. And I should be able to see this thing tighten up. You can see those threads are screwing down into that hole. Clockwise to tighten. Righty-tighty. Counterclockwise to loosen. Here it comes out. And there we have it. So external threads made with a die, internal threads made with a tap. And of course, if there's any questions for me, you can certainly put them in the comments. And I'll probably do another one later to talk about the specifications of what 1/4 means and what an M8 bolt would be in metric and so on. Thanks for watching. Okay, just a quick follow-up to make sure, I don't know if I was totally clear on some of the things. Again, this is the 1/4 threads on the rod, and because I didn't have one handy at the moment I was doing the recording, I got a 1/4 nut from the closet, and we want to see that go on there. That fits just nicely onto those threads we made, and it's just the right size to screw on there like you would expect. Okay, so that's a 1/4 rod that we made, 1/4 threads that we made with a stock 1/4 nut, bought from the supply house. And of course, again with this piece of steel here, I made this hole right here today, this third one up, and this a 1/4 bolt, also from the closet, from the supply place. And we should see that be able to turn very nicely into that hole, right? And you can see, yes, indeed, the hole size we made and the tap we used is a standard setup. It fits with this standard 1/4 bolt, 1/4, more technically 1/4 machine screw, right? So that's a good thing there. It tells me that what I did actually worked. Anyways, now I scared you with that big close-up of my face. Thanks for watching.